Okay, we're going to discuss the halogenation of methane next, and this is going to apply not just to methane, but also to other alkane structures, right? So the overall mechanism for the free radical halogenation of methane will be, we're going to have methane, CH4, and we're going to use chlorine, Cl2, in the presence of light. Light is our activating agent here. And we are going to replace one of the carbon-hydrogen bonds with a carbon-chlorine bond. Right? So we're going to make chloromethane as our product. Right? We're just going to show one cycle of this today. Okay? So remember, for free radical reactions, we have multiple sort of steps and stages. So the first stage we have is the initiation step. Right, so we have to generate radicals in order for this reaction to occur. Right? So methane, chlorine, we don't have any radicals, but we do have light, and that's going to activate one of these bonds, and we're going to break that homolytically. So first, we're going to start with chlorine. Right? And we're going to, our activating energy will be light. Right? And so for this mechanism, we are going to homolytically break the chlorine-chlorine bond. So we're going to evenly break these, and we're going to use our electron arrows that only have half of an arrowhead, right? That symbolizes the movement of one electron. And so the product of this step will be two chlorine radicals. Right? And each of these chlorine radicals can go on to do further reactions. And these further reactions occur in the propagation steps. So in the propagation steps, we take a radical that we just generated, and we're going to convert it into a new radical. Okay? So the first propagation step we're going to do, we're going to start with chlorine, our newly generated chlorine radical, and we're going to have that react with our methane molecule. And I'll just draw out one of the carbon-hydrogen bonds here. Okay? And in this first step, our chlorine radical is going to react, and it's going to cause a homolytic cleavage of the CH bond. So our chlorine is going to react, and it's going to form a bond to hydrogen. And we're going to be left with a radical on carbon. Right? So the product of this step will be a new HCl bond and a methyl radical. Okay? So we've converted the chlorine radical to the methyl radical. The chlorine did this by abstracting a hydrogen. So this step is often called a hydrogen abstraction. Okay? So after this step, we've generated a new radical. Let's go ahead and use that to continue the steps. Right? So we have our methyl radical. I'll draw it facing the other way. And now it's going to react with something else. It's going to react with our chlorine. So here we're going to have methyl radical, and it's going to form a new bond to chlorine by homolytically cleaving the chlorine-chlorine bond here. Okay? And so the product of this step will be, we're going to make our new carbon-chlorine bond, which is in our final product here, and we're going to regenerate a chlorine radical. Right? And so this chlorine radical can go back to this propagation step and abstract another hydrogen to generate another methyl radical, and then that methyl radical can react with another molecule of chlorine, and it sort of continues this cycle over and over and over again. This second step, where the methyl radical is reacting with chlorine, it's abstracting a halogen. So this second step is often generalized as a halogen abstraction. Okay? So once we identify a set of propagation steps that sort of can act in a loop, we're going to move on to our final stage of reaction, and that's the termination step. Okay? The initiation step generates radicals. The propagation steps convert one radical into another. The termination step takes two radicals and combines them together in order to sort of eliminate the radicals. We don't have any radicals at the end of the termination step. So when the reaction sort of slows down and all of our methane is converted into chloromethane, eventually we're going to do a termination step where two radicals react with each other in order to form a bond. So for termination steps in general, you can pick any two radicals that you generated throughout this reaction and combine them. So we could say a termination step would be recombining two chlorine radicals. You could combine a chlorine radical with a methyl radical. So we'll do that one. So we're going to take one of our chlorine radicals and we're going to react it with a methyl radical. And so drawing in our arrows, we're just going to draw these two radicals together, forming a bond. All right? And so in this case, our termination step generates another equivalent of product, but that doesn't always have to be the case. Sometimes the termination step is the source of different contaminants. So in the case of this reaction, we could regenerate chlorine gas, or we could generate an equivalent of ethane by two methyl radicals combining. So you can combine any two radicals you want in the termination step. So remember that when you do a free radical reaction, you have to identify all the reactions that occur in these three steps. You need an initiation step, you need a propagation step, and then finally you need a termination step.